gonna jump right into it. Don't mind the bad video editing. I'm an engineer, not a video expert, so you're just gonna have to deal with this. Me stopping and pausing videos to do everything. So first off, if you watched my last video, I was gonna do a chain, but then I decided against that because it was a 1/4 inch or 1/4 inch pitch. So I found a GT2 belt on Amazon. So that has a pitch of 2 millimeters. So way more teeth grab these with the belt on a pulley than with the chain. So I ended up going with the belt. And this is just a quick montage of printing one of the drive sprockets. The reason why I have a raft, this is called a raft. The reason why I have that is I was used to PLA. This is actually PETG plastic. PLA takes a little bit more, or at least I was having a problem with it adhering to the bed. So the raft made it adhere. Once I printed one of these, I did a skirt instead of a raft, which actually gives you a little bit better quality and uses way less plastic. So after I printed the dry sprockets, the 3D printer doesn't really have a high enough quality to print down to the thread set screws I'm using. So I actually just left it as a hole with no threads. It ran a metal tap through it. Worked perfectly fine. This is actually a video of me building the control box. I built a control box out of wood. Didn't really like it, so I said, screw it, I'm gonna make it out of plastic. So I had this sheet of PETG. It's pretty much see-through. Looks pretty cool. Laying around. So this is a quick video of just my CNC cutting it out, and I actually have it so it's gonna cut it out in 3 passes, or 3 or 4 passes. And of course, this is on my CNC mill, so pretty much once I got the sides cut out, everything bolted straight up. You can see my aviation pins right there. And my fan cooler bolted pretty much straight up. And we found a small 12 by 12 perforated metal little sheet, which worked perfect because we actually drilled self tappers down there to hold everything. So if you're gonna build a control box, pretty much all your wiring is right here. Excuse my absolutely atrocious handwriting. So the YA and X in my driver. For A plus, I have a black wire, A minus white, B plus gray, B minus purple. And then into the plug, the female side, it goes black, white, gray, purple, and these numbers coincide with the pins. And then this pretty much is the male end of the plug. So black to black, white to white, gray to red, and purple to green. And then it gets a little funny when you go to the motor. So the wire out of this has black, white, red, green, black, white, red, green. So the black goes to black, the white goes to green, the red goes to red, and green goes to blue. It's kind of funny just because if I wanted white to white here, I would have needed white to green there, and just that's the way the wires kind of worked out. I could have switched them up, but then I would have had loose wires. I wouldn't have those nice ribbons. And then for the YB, since it needs to go the other direction, um, this is the driver or the stepper driver that's in the box. We want it to go the other direction, so we switch the poles. So pretty much A plus is going to be B plus, so gray. A minus, we want it to be B minus, like on YA and X, so purple, black, white, and then you just kind of follow the um same pattern here, and that pretty much gets you. So the YB spins counterclockwise, and the YA spins clockwise. And then also with the relay, because the relay requires 3 plugs. So I did brown for ground, red for the 5.5, and then orange for the signal voltage. And then I have a plug. I used blue and green wires, and they go into pin number 1 and 3. And NO means normally open. So pretty much when wiring a box, this is what you need. And then also, this is everything that goes into the Arduino. We're not going to use the Z direction on ours, so we only have to worry about Y and X. For the spindle enable, that's your orange. Stepper enable, I made it white, and then gray, green, light. This is pretty much just what you need. And then for the power, this is a 5-volt pin, so that red pin goes into the trigger or the relay. The brown is for the ground, negative, common, whatever you call it, to the relay. And then this ground actually goes to, in the stepper motor drivers, they have direction and pulse. Each of those need a ground. So you actually just bring a black to one stepper and jump it across and jump it across and jump it across. With mine, this is actually pretty important. With mine, the ground, this ground was not sufficient enough for all of them. So it's actually jump goes into here, goes through all of them, and then I also have a jumper cable that runs to my 36 volt power source. doesn't matter. The ground means 0 volts, so that's 0 volts, and it's 0 volts at the power box. And then here's a kind of final picture, not really final. I didn't have the top glued or anything. But this is the basic layout of the power box. We have our Arduino right here, and man, this one fan, I think it's 120 millimeters, or maybe 220. I forget what the computer fan is. That fan actually kicks so much air through there. If you put your hand on the other side, you'll get a chill. And then there's my 36 volt power supply. Alright, so in here we have a quick overview of the whole machine. It's actually pretty much done. It cuts and everything. The only thing is I don't have my water table. So I just gotta kinda hang off the piece of metal from the end. And you'll see that in a second. But so first off, that plug is an aviation plug. Our machine, our plasma cutter, is so old. This is pretty much when plasma cutters first came out. It doesn't have an external plug. A lot of the new ones have plugs like that aviation. So we actually had to open it up and jump 2 wires to make that plug. Besides that, the plasma cutter is can adjust the amperage. It's 30 amps, and so I mean that's a very weak plasma cutter too. And all you can do is adjust the air pressure. So you can see it runs over there to my control box. There's a quick overview of the whole machine. So quick overview of the whole thing. This is how I held the belt on the one side. This is not the side with the adjustment. So just kind of one bolt and a tooth thing to pretty much hold the belt. And that's not the side I give the tension on. So in this you can kind of see the layout I was talking about with the drive sprocket and the 2 idler sprockets or pulleys. And my linear rails, I should actually jump into those a little bit. But this is an 80 tooth, and it's 40 teeth on the other side. So as long as this belt is straight, this belt doesn't matter. Because if you think linear motion, if you tell the motor to move, let's just say 1 inch, it'll move 1 inch here, but and 1 inch at an angle on here. So it might actually only move if the belt was attached here to the linear rail. It might only move like 0.8 of an inch. So you gotta make sure wherever you attach the belt to pull the linear rail is straight. I don't have my gantries welded down. Right now they're just kind of clamped in there. Not really a huge deal. And then right there you can see my, this is pretty much how I tension it. You loosen these two, and then pretty much you just pull the belt, and you tighten them down, and the belt will go back and forth, and it's actually enough tension to, hold and clamp it down. Yes, you can make fun of my crappy spot welds. So that's one side, and like I said, I don't have the water pan. In order to get it cut, I just found some angle iron and kind of hung off pieces from the side. On this side, we see another tensioner. There, those welds look a little bit better. Judge me on those, not the other ones. I'm not a welder. Same thing with the belt on this side. And then I 3D printed this motor mount. I found out how much offset it needs to make the belt nice and straight to where it attaches on the linear rail. And then, so I just 3D printed that. And then, excuse my wheelchair. Doesn't like to go over those. And then this is a 3D printed torch holder I made. So when you have the water table in, you whenever you want to adjust the height, you unscrew these four big black nuts, and you can actually slide that all the way up, and you can actually have an inch of clearance, and the water table will not. It'll pretty much sit right in the middle of it. I just did a zip tie on this side, and that side's actually kind of bolted and clamped. The zip tie's just kind of, it's, I don't know, extra support. A lot of, you see a lot of these online where they only are held there. I think that would be fine, but if this gets snagged on any kind of piece of metal that's flung around or whatever, I don't want that to rip off. And right now everything's kind of mockly wired together, and you can see it goes over to the control box. So this was the finished control box. Sorry about the video being sideways. I broke my phone or my camera, and I'm recording on my phone, but I made a little flappy lid so I can get into there. And again, sorry about it being sideways. It's really not, the wiring looks crazy, but if you write down those little pieces of paper, the guides I did, you should have no problem doing it. So this was actually my first cut with the machine. Chose this, it was first cut, or not really cut. It was the first thing I did on the CNC mill when I built that. I had a pencil on it and kind of like drew circles and filled it in with circles. It came out pretty cool. But but I'm actually kind of amazed. First cut, just kind of set it to 50 inches a minute. And it cut pretty good. This is about, what is it, 16 gauge? Let me get my gauge meter. I know which one it was. yeah, so it was 16 gauge, which is probably the most that plasma cutter is gonna handle at 30 amps or whatever it is. But yeah, 16 gauge, and I set the cut speed to 50 inches a minute, and it did pretty well. What I think I'm gonna do is the cut speed. I think is okay, but I think I need to up the acceleration a little bit. If you look like around his hand, if you think it's pretty much going there, stopping, and then coming down to here, stopping. So around these detailed cuts, the acceleration is more of a factor than the speed, and you can see there's more bluing around these detailed cuts. So I think the torch is actually there a little too long. And then if you look on like the arm all the way down, there's pretty much no bluing on the side. And then once you get down to these detailed cuts again, you get a lot more bluing. There's actually a really bad bluing spot right here. The blue is all the way from the corner up to here. Because it's such a sharp angle. It's stopping and it's taking too long. So I think that is gonna be, I need to increase my acceleration, not my max speed necessarily.